This is what my Logix Pro simulator looks like. In order to access the input and output simulations, I can simply go to simulations right here and click on the I/O simulator. So what this does is that I have all my input simulators and outputs right here. So as for my inputs, I have them in different forms. I have some switches. This is an open switch. This is a closed switch. Some toggle switches here and there, and it goes on until like the end of the list. And we also have the output, which is going to be all sorts of lamps. So I have a lamp right here. It's in green, and the others um, following right here. So this is where we'll be doing most of our ladder logic code itself, and we'll be using these components. So for today's assignment, I guess, I will try to make a very basic, simple ladder logic where if we press on a toggle switch, a lamp will turn on, and if we lift it, it stops. So in order to do that, I'm gonna have a normally open contact right here, and I'll copy paste the address of this switch. I would also like to rename this as a toggle, and I will have an output, which is this symbol right here, and I would like to give the address of this lamp to the output, and I will name this as lamp. So essentially what this does is when we press on the toggle switch, it closes the it's there, it energizes this rung and the lamp is turned on. In order to see this in action, we can simply press this button right here. We will download it and run the program. So as you can see, when I press the toggle switch right here, my lamp is energized, but once I lift it, my lamp stops being energized. So if you wanted to follow the same concept and have, instead of just having one toggle switch, what if I want to have two toggle switches? So that would be a concept of add and operator, which means that I want to have two toggle switches to be on in order for the lamp to be on. So in order to do that, I'm simply going to go here, and I will have a normally open contact, which essentially turns on once my toggle switch signal is on. And I want to use this, and I will click the right button to go through the switches, and I have another toggle switch right here. I will copy paste the address of it, and I like to rename this as toggle 2. So essentially what this does is that when both of these toggle switches are energized, the lamp will be energized, and if either one of these are off, the lamp will stop running. And to see this in action, we can simply go here. I will download my PLC. I will run it and see it in action. So you see how both of my switches are on, and this energizes my lamp. But if one of them is off, my lamp stops being energized. And if both of them are off, my lamp is obviously turned off. And in order to turn on the lamp, both of these switches should be on. And this is the AND operator in ladder logic, where both conditions should be true in order for the output to be true as well. And if we want to apply the same concept, but for OR, where we want one of the toggle switch to be on, in any of these toggle switch can be on in order to have our lamp on, we can do it by going back to here, and I will have a normally closed contact, and I will copy paste the address of this toggle switch right here, and I'll delete this. So essentially what this does is it only turns on if one of them is off, if one of them is on, instead of having both of them on. So to see this in action, I will download my code and run it. And as you can see, when both of my toggle switches are pressed, my lamp doesn't work. But if I release one of them, my lamp turns off. But if I release both of them, my lamp stops working. So that is it. That is a condition of OR. However, it only works if the first toggle switch is on and the second toggle switch is off. If it's vice versa, it doesn't work because my normally closed contact is only for toggle switch 2. So I'm going to be using the same concept for my motors, and I will basically build a start and stop switches to start my motor and stop my motor. So essentially to do that, I will go to simulation, input simulator, and I will start with a start switch, which is going to be my normally open contact. And I have this start switch right here. I will copy its address, and I'm going to rename this as start. And once I press the start switch, I want to energize this lamp. So I will have, or a motor, and I will copy paste this address, and I'm going to rename this as motor. Essentially what this does is once I press on the start switch, my motor gets energized. However, there is a flaw, but I will show you that in a bit. So I'm going to download the code and run it to see it action. If you look at this, once I press the start switch, I have to keep holding onto it for my lamp to be energized. And once I let go of my finger from my mouse, the lamp stops working. So we want to have we need to develop our logic in such a way that once we just need to press onto the start switch once and the lamp continues to stay energized. To do that, I will basically have a rung branch, which is this right here, and I will put that there, have my start inside, and I'll have a normally open contact, and I will copy paste the address of my motor right here. Right here. So essentially what this does is if I press the start switch, it will go through this rung right here and it will energize my motor. And the second time, because I'm not pressing onto the start switch, it will go through this line right here and it checks and it sees that the motor has already been energized. So it continues being energized and it continues be like energizing the motor as well. So to see it in action, we will download the code, run it, and right here, once I press the start switch, even though the start switch is off, technically, the lamp still runs or the motor is still running. And now we want to include another logic where if we press this stop switch, which is a normally closed switch, the lamp will turn off. And in order to do that, we will add a normally open contact right here, which is outside the rung. And I will copy the address of this switch. I will want it to be a stop switch. So essentially, regardless of how it comes through here, if I have pressed the stop switch, it will stop energizing the motor. So let's see it in action. I'll download the code, run it, and hold on, download the code. run it. All right. Once I press the start. Yeah. There you go. So once I press the start switch, it starts running. And if I turn it off, and if I press the stop switch, it turns off. Start, stop, start, stop. And there you go. There is another way of doing the same concept by using latching and unlatching, which is quite useful if you're working with a lot of um, like latching and unlatching components. So we can go back here, and I'm going to convert this into a start switch and this into a stop switch. So to see that, I have my normally open contact, which is going to be my start. So I'll copy paste the address of the second start switch right here. And this will be my start 2. And I will use, instead of using the output energize, I'll be using output latch. What this does is that once it is energized, it latches onto it and it continues energizing the motor. So I'll copy paste the motor right here, the address of the motor, and the way you can see this in action, by pressing the run button. So if I press the start switch, it runs. Press the stop switch, it stops running. The same concept. Press the start switch, it runs. Actually, it might be better if I ran this light. Oh well. But now we need to follow the same concept for the stop switch. This time, I'm going to use a normally closed contact and use the unlatch component right there. And I'll copy paste the address of the motor, and I'll copy paste the address of the stop switch right here, and this will be my. So essentially, what this does is the reason why we have a normally close contact over here is because. So the reason why we have a normally close contact is because it will be low or 0 when in its normal like position, just like right here, and it will be high once we press onto the button. And once that happens, it will unlatch the motor, so it stops cutting off. It stops the power supply to the motor itself. But yeah, that and let's see it in action. So I will download the code and I will run it. So we can see once I press the start button, it keeps on latching, and once I press onto the stop button, it stops latching. So thank you. So this is how I would solve this problem. In order to start, I will begin with my start switch. So I have my 2 start switches right here. I'll just make this 2 start switches and 2 stop switches. And in order to begin, I am going to do a normally open contact for my first start switch and my latching output. The reason why I want to do latching output instead of the traditional rungs is because I am going to need 2 um, start switches, and I find it difficult to just use the traditional way. So I'm just going to give it the address of this lamp right here. So I will drag that. I will rename this to be start 1, and rename this to be lamp. So essentially, as from the earlier tutorials, we can see that if I turn on this lamp, turn off the switch, the lamp will turn on. But now I want to add another switch that would still turn on the lamp even if we press that switch. In order to do that, I'm going to add a rung. I'm going to drag this in here, and I'm going to have another normally open contact, and I will add the address of the second start switch right here, and I will rename this to be start 2. And what this does is that once I press this button, it will go through this rung right here, and it will latch onto the lamp. The same concept with, let's say if I start this start switch, it will go on through this rung right here and energize the lamp. If we want to see it in action, this is how I would do it. This is what it would look like. I'm just going to run the program, and you can see, oh, I forgot to add the stop switch, but it would essentially do the same thing. So I'm just going to add the stop part real quick. So the same concept as I did earlier, I would have a normally closed contact right here for my stop switch, and I will copy paste the address, rename this to be stop 1, and have a unlatch output, and I will copy paste this lamp address right there. And then the same concept that I can press either one of these buttons for it to stop. So I will include this, drag it in, and have another normally closed contact for my stop 2. And we'll drag the address, and this is going to be my stop 2. So the same concept. If I press this stop button, it will energize this, and unlatch the lamp. The same concept where it goes through the second stop. To see this in action, I will download the code and stop button, and it stopped. I press the first button and the lamp ran. I can press the second one to stop the lamp, and this goes on and on. Regardless of any button I choose, it will either start the lamp or stop the lamp. That's it.